Okay, we'll go ahead and get started. If anybody's running late, or I did send an announcement that we'll go over, but I had a couple people asking if they could, stay home intermittently, and only show up to class maybe if they're having issues. So we'll talk about this. So let's go ahead and get started. I see a few familiar people in here. How many people have had a class with me before? Oh, okay. So most people. Okay, so you kind of know the deal. How I teach and so forth. Okay, so for those that haven't, my name is Dr. Bakeley, so it's Bakeley. It's okay if you forget. It's a difficult name to pronounce, I know. Usually it ends up happening about halfway through the semester. People forget, and either they pronounce it wrong or just say professor. So whatever. The best way to get a hold of me is going to be by email. So I have an office phone, but even during the pandemic, I'm teaching a lot of live classes, and I have meetings and other things, and so the chances of you actually getting me when I'm in my office sitting around for a phone call are pretty low. So the best way is by email. Everyone's wearing a mask, correct? Okay, let's sort of quickly go over coronavirus related things. I think for most people in here, this is your first class of the semester, correct? Show of hands, anybody had any 8 a.m. classes or anything like that? It's pretty much everybody's first class. So obviously we're in a difficult time with the pandemic. Sort of interesting that so many students actually signed up for live classes. I'm teaching, almost all my classes are live classes, and they filled up almost instantly. So just out of curiosity, if anyone wants to share their reasoning, because there is an online section of this class, just name the reasons why you decided to take the class live, even though you could have taken it online. Yeah.
I feel like I learned better.
Okay. How many people would agree with that? You just feel like you learn better in the live setting? Okay. That's sort of why I decided to take on live classes, because I'm sure if I really made a stink out of it, I could have probably had more online classes. But programming is very difficult to learn online. Has anybody taken an online programming class before?
It was terrible.
So yeah, would you agree they tend to be probably more difficult than they need to be? Yeah. So now, I'm sure if you had your way, you would probably take it live, but there's a million reasons that you can't. Work schedules, sometimes they don't get enough students to make for a live class, so they'll put it online. There's a million reasons that stuff gets offered online, but so as I mentioned, we are in the middle of the pandemic. There's some level of personal responsibility. So I'm guessing most people in here, this is not your first semester at IRC. Okay, so as students get older, I've noticed that college students tend to mature pretty quickly, and so I don't tend to have to go into the same speeches that I have to do for first semester freshmen. It should be obvious that if you come to class and you have coronavirus, what happens to the rest of the class?
Shut down.
Yeah, you may not have given it to anybody else, but just the fact that you showed up to class means that everybody has to quarantine. If you're taking 5 classes, or let's say 3 classes, and you're working a job, that really screws up that person's life. Would everyone agree?
Yeah.
So if you feel that this is going to be an issue for you, I guess I can get into this now. I posted an announcement. So I already got the sense that most people in here, the reason that you are taking it live during this, relatively dangerous time, is that you still wanted to learn something along the way. And I guess I can make this larger here. Okay. Now, there may be local outbreaks or times that you don't feel comfortable going to class, and I'm perfectly okay with that. And you may want to do some things like alternate weeks, or maybe every 3rd week don't show up to class. You can come up with your own system. The one thing I do ask is, so I'm recording all these lectures. Let me just double check that I'm actually perfect. Okay. And they're both recorded and live streamed. So if you're the type of person who needs to be at a desk at 11 a.m. watching it live, you can do that. Just go to the live stream and you can view it live. And maybe if there's enough demand, I'll do something where I'll set up like a side chat or something like that where people can ask questions. Maybe I'll set it up on this main desktop here. So the requirements to do that, you have to have a reliable computer and internet connection for obvious reasons. And I know not everybody does, so just be honest with yourself. If you don't think you're going to have a reliable computer and a reliable internet connection, don't try to make it happen, okay? I heard some talk, I'm a little bit hesitant to say this, but I did hear some talk about between grants and other things that there might be some laptop computers available. I've never actually seen one make it into a student's hands, but there was a lot of talk about that, especially during the spring. I don't know whatever happened with that, so that might be a possibility. I'll see if I can find out more information. There was a lot of talk about it, but then when it came time to actually put laptops in people's hands, I haven't seen that happen yet. It might have happened, I just haven't seen it. You must have access to 2 screens. So I say 2 screens very vaguely. So in this class, this is a programming class. And the way I've noticed that most students tend to do well is I write some code up here. This thing's going to keep on falling. Sorry. I write some code up here. We talk about the code for a little bit, and then you write it on your computer. There's some effective muscle memory of actually typing it out. There's just something, I don't know what it is, I can't explain it. Just the act of typing out the code that I write up there, there's some learning that goes on in that process. It's strange, but for whatever reason, it works. And I've noticed this myself. I'm still an active student. I take Coursera courses pretty much every summer. I take programming courses on new languages. I'll read programming books. So I'm an active student too. And I know the challenges you face, and I know that you can't just read a programming book. You can't just watch a programming lecture. You have to actually write the code. There's just something about it that helps you learn. If you're on, say, a laptop with, just really quick, can everybody hear me in the back? I know it's a little bit tough with the masks, but everyone can hear me? Okay. So if you've got a laptop and you're watching the lecture on YouTube, you look at some code, and then you have to minimize it, and then, or you might try to tile your screen side by side. It just doesn't work out that great, because once you start tiling things side by side, the fonts get very small, or you might have to scroll. It can get somewhat difficult. So what I'm asking is that you have access to 2 screens. Now I'm being generic about that because that can mean a lot of things. Because I'm doing this through YouTube, what that means is that if you have a smart TV, Chromecast, there's probably, I tried not to do an extensive list because there's probably 50 different ways that you can watch this on a TV. You just go to YouTube. I think you can just type in my email address and I think it comes up. But there's a bunch of ways to get it on your TV. And then if you have a laptop or whatever, you just need to be able to watch it. You just need to simulate this experience right here of having a screen up there and having a screen in front of you. Now, some people have dual monitors, but I'm noticing as more and more people get laptops, dual monitors tends to be more generally, I notice, with gamers. I have dual monitors, but just because I do a lot of programming. Out of curiosity, how many people have dual monitors at home that... Oh, okay, so the bulk of the class. Okay. And then everyone else, is there anybody who... and then just out of curiosity, how many people, regardless of whether you have dual monitors, have some sort of smart TV or something that you could watch it on? Chromecast, anything? Okay, a few people. Okay. So those are the 2 main things, is that you have to have a working computer and working internet, and then you have to be able to sort of replicate this experience of looking at code on one screen and typing it on your computer on the other. And then some of this other stuff is probably pretty obvious. Watch the lectures right away. Don't let a bunch of weeks accumulate and then try to watch 3 weeks at once because it's very difficult. And then you kind of get just lost and then it's hard to catch up again. Stay in constant communication if you have any issues. Like I said, email is the best way. And then you have to feel somewhat comfortable programming. I'm not expecting people to be expert programmers, but you have to be able to, everyone in here has taken COP2030 or some other similar course. How frustrating is it when you have a syntax error? Pretty frustrating. After your first programming course, you can get better at spotting those. So I'm not expecting anybody to be an expert, but I want you to get to the point where you can find your own syntax errors. One of the main reasons I think that programming courses are so difficult online, and I've gone through this personally because I teach them every once in a while. If you have a syntax error, can you really make much other progress on your assignment?
No.
Not generally, no. I mean, you can write code, but you have no clue what that code's going to do because the point that the syntax error happens, that's where you've essentially stopped. In an in-class setting, I walk over. I've been doing this, between this class and the Python programming and programming in general I've been doing. I look at it and I say, okay, that's the syntax error. Syntax error is just an experience thing. There's no quick way about it. You just have to write a lot of code and you get good at spotting them. If you make a syntax error at home, you might spend days emailing back and forth between your professor. How many, just out of curiosity, you don't have to raise your hand if you don't want to admit it, but how many people ran into that with online programming classes, that you'd get an error and then you'd go back and forth with your professor actually trying to get that? Yeah, it's pretty frustrating, right? Yeah. What's nice about the in-class thing is I can just look at your code and I can usually, maybe not within 30 seconds, but within a few minutes we can, and even if I can't see what the syntax error is, usually somebody with better, younger eyes than me can look at it and say, oh, you're missing this thing here. Okay. So that's pretty much it. I'm sort of assuming everyone in here is, you're a little bit older than the first semester people. So I think most people in here have like a little bit of maturity. You've done college before, you know what it's about. So I'm not going to spend too much time. We'd like to write a little bit of code today. Let's very quickly go over the rest of the syllabus. Any coronavirus related questions? So just to very quickly summarize, you're welcome to come up with your own schedule of staying at home. Really, the only thing that is required is the midterm and final. And even then, say we have a local outbreak, we might have to come up with some other creative solution for doing the midterm and final. So, so as long as you can, meet those requirements of having a reliable computer, a couple of screens, you're good at being reasonably self-directed, you can maybe show up every other week, every third week, once a month, whatever. And then if you're just going to just do everything at home and then do the midterm and final, just kind of shoot me an email every few weeks. Just let me, even if you're doing fine, just check in and say, hey, been watching the lectures, I'm all caught up, doing the assignments, I'm doing fine, just so I've heard from you. So now let's talk about the actual course. So this is Python programming. It's tough for me to say if this is any easier or more difficult than previous classes, but at least I think everyone in here is supposed to anyway have had some sort of previous programming experience. So programming is a little bit tough in that, let's take another subject that's known for being difficult, is math. Now the thing with math is it can be difficult, but for most people they've been doing math since elementary school. Right, you start first grade, second grade, maybe even kindergarten, you start doing very, very basic math, and then you build up over a time. That's not the case with programming. I mean, there's a little bit of effort going on in high schools to learn programming, but for the most part, most students that I've seen, their experience has been in college. Like, some people learn outside and other things, but I would say, if I had to guess, 80% of people are learning in college. That is a little bit tough because, this is your very first experience programming, and it's, in your adulthood, and like we were just talking about, for some of you, your first experience might have been online, so it gets tough. But just like with everything else, it gets easier over time. So this programming class might be a little bit easier than your first programming class. If this is your third programming course, it's going to get a little bit easier. Just like everything, it's experience and practice. I always say with these programming classes, they tend to be much more of like a welding class or like an electronics class where you're learning how to solder or something like that, versus, let's say, a history class. A history class, you go in, you read the book, you make some notes, but there's not really a lot of hands-on. Yeah, like you don't have to practice anything. Let's see if I can do something like this with it. It's not going to keep on falling. Okay. With programming, it's a little bit different. I always compare it to something like welding, is that it's one of those things, yeah, there's some theory behind it. There's some safety, obviously that's welding specific, but you learn a base set of principles, and then what's the best way to get good at welding after that, once you have the base information? Just doing it, practicing it. And I think that's true with programming. So one of the ways I lecture, and I've kind of already alluded to this, and some people have had programming classes with me before, is that when I lecture, I write code, and then I have you write code. And that's probably one of the best ways to practice. And then really the best way is to write code just that you're not copying, and that'll be the assignments. Let's get down to that part of it. So like I said, to me the best thing is actually writing code. That's why I don't get into the discussions and the quizzes and all that other stuff, because to me that's a little bit of a distraction. To me, the best way to write, like I already said, I'll give you some base set of information, some principles, like, oh, this is how you do an if statement or conditional statement in Python. But then let's just start going into some examples. We could go all day into theory and all kinds of, bunch of information that might be important, but it's not really helping you along the way. So to me, those programming assignments are the most important, and because of that, they're worth 70% of your grade. Now, I do a midterm and final, but I realize some people get test anxiety. They're not the best test takers. There's only so much I can ask in 1 hour test. And so those are worth a little bit less. And to me, that kind of pulls a little bit of the stress off the course, because okay, even if I just completely bomb the exams, I just do terrible on them, I could still theoretically pass the course as long as I'm doing pretty decent on the assignments because of the way it's weighted. I realize a lot of people in here have very busy schedules. You work, you do other things as well. And that's why I don't get into the participation grades and all these other things, discussion boards and stuff like that. Because to me, if you have a set number of hours to spend on a course, wasting an hour on a discussion board, to me that's like not a good use of your time. You could have spent that hour learning how to program, So that's why I really try to just get it down to the core, the base things of the course, the things that I think are most important. And as you can see here, your grade is going to be 100% based on programming. Now don't let that scare you, because like I said, I'm usually pretty helpful with the assignments. I usually try to give you 1.5 to 2 weeks for the assignments. So not 7 assignments, 7 to 8, that seems to be about the number. And then the midterm and final are programming exams, but they're going to be directly based off the assignments. And I think how many people who have had me before would you say that's pretty true? Maybe not 100%, but it's mostly true that you'd say the assignments and the exam were pretty close. Now, I say that's mostly true because I've had people in the past write me nasty emails afterwards saying that the two were nothing alike. But in general, it's my goal anyway to try to make them somewhat similar. Okay. Okay, so I think that's pretty much it. Like a lot of the syllabus, I don't even write. It's like almost reads like a legal document. Let's talk about some other things. So I almost don't even think about this anymore. The book prices have gotten a little bit out of hand. The course that I was doing before this, the book is $200. That CIS 1000 book. Does anybody have to take that course, CIS 1000? Book's kind of expensive, right?
It's now $300.
Oh yeah, it's getting out of hand. There's instances where the books are as much as the class, and I don't agree with that. I think there's we're in a field where I don't think there's any other subject out there at all that you can find more information on the internet. Does that make sense? Because if I were to type in Python programming right now into Google, there's people who have published high quality entire books on the entire language. That might be a little bit more difficult in something like, say, I don't know, a history class or something like that, English class. There's probably still a lot of information, but compared to computing and programming, there's just a huge amount of information out there. And to me, it would almost be unethical to require you to go out and buy a book when there's just so much free information out there. Now, in the past, that's gotten a little intimidating for some people because they just like to have that book in front of them. They like to have that. I do provide some resources that are kind of book-like. For the most part, the course is actually pretty much self-contained. But under resources here, you'll see a couple things that are kind of like follow chapters in a book. And I'll kind of, for most programming courses, there's a natural progression. You learn about print statements, input, output. You learn about variables. You learn about conditional statements. You learn about loops. You learn about functions. No matter what the language, no matter what the class, they tend to all follow this structure. So the books tend to follow it as well. This website seems to be halfway decent. I've used it in the past. And you can see it pretty much follows variables, basic operations, conditionals, loops, functions, just like I was saying. And here's another website that's pretty decent. This one's more web focused, W3 Schools, but they're all going to follow the same basic. You can see here variables, data types, numbers, if statements, loops. They all tend to follow that same basic structure. So one of the things that's gotten kind of thrown people off in the past is actually installing the language to write software. Has anybody had to install Visual Studio? The regular one, not Visual Studio Code, but the regular one. It's not a fun process, is it? No, it takes a long time. There's a lot of options. It's kind of difficult. So for most of my classes, so in the real world, you tend to use software like that. They're called IDEs. Visual Studio, they have a lighter version called Visual Studio Code. You tend to have to set up a whole environment on your computer. But that's not what this class is about. And I've sort of come up with some shortcuts and some ways around that. Now, if you're going to be writing Python code in the real world, we can actually defer that toward the end of the semester. When I was taking computer science classes, a lot of times we'd burn like 1 to 2 weeks in the beginning just setting up your environment because it can get very complicated. With internet connections as fast as they are and virtualization technology as it is, there's actually an interesting site. They're called, I don't know if they have an official name. I always just call it REPL. Yeah. They've got a huge number of languages that you can write code in. And you just write the code, you run it, and this is just your terminal. It makes life much, much, much easier. And so for the most part, I've switched to this. Now, there are limitations. I couldn't write a game in this because, or like say a graphical game, I could write like a text-based game, but I couldn't write a graphical game because it's in the web browser and it doesn't have access to my graphics device. I couldn't run a web server on here and write web software, but we're going to be mostly focused on the fundamentals and the core of the language. And it's actually pretty impressive because there's things in the past that I thought it couldn't do that it turned out it could. And we'll get to that later in the course. So in some cases, we might, for some students, because toward the end it gets a little bit more open-ended, we might be able to just stick with this the entire semester. So that would be nice. But just so you know, so under course resources, this is what we're going to be sticking to for the most part. And we're not going to be writing code just yet, but as you can see here, it's literally as simple as I write some code here, I run it, and it runs over there. It's very simple, and that took me 2 seconds to get started versus spending, an entire lecture trying to set up some environment. So that's what we're going to stick to. Now, the environment's essentially going to be agnostic. Anything that can run Python code, I'm okay with. So I'm not going to be super picky about that part of it. I just need you to write Python code, and to me, this is the fastest way to get set up. I've had students struggle and just get behind on the course because of stupid software-related things, and I don't want that to happen. So I would say just the easiest path. For the most part, actually, almost all my courses I've gotten onto this. The only holdout is that Visual Basic class. I think I had a couple of you in there, and there's no way around that one. You just have to install it. It's not fun. It takes a while. But once you have it installed, then you can get past it. But for the most part, I've been relying on this, and it's been reliable. The other nice thing about this site, and this is very frustrating for a lot of people, is that when you write software in these IDEs, a lot of times they have extra files that are specific to the IDE, like a bunch of XML files and resource files, but then your actual code file can actually be a little bit difficult to find. And sometimes what happens is you grab the wrong file and you do your project at school, you plug in your flash drive, you think you've got all the files, you get home and you've only got half the files, and then you're like, oh great, what do I do now? This site actually, if you sign up with an account, it's I'm pretty sure it's still free. They actually keep all your code for you on their server. So you can work on a project here, get home, and then you've got all your source code available. Now, I would go to some effort to make backups, because I don't know who runs this site. It's been around for a few years, and I don't know if it's volunteer-based or if they plan to commercialize it at some point. I think they had something where you could commercialize it, I don't know, but I would still have backups. It's just always good to have backups. I don't really trust the cloud that much, just in general, because there have been some smaller cloud services that just one day went away. I don't think, obviously, Google or Microsoft with their cloud services are just going to go away. But a smaller place like this, who knows? You know, they may lose your code. So just maybe every once in a while, maybe at the end of class, just I think there's like a download button or save button or something like that. Yeah, download a zip. Maybe just download the zip to your flash drive just so you have some backups. But for the most part, I haven't seen too many people have any problems with this site. But you never know. It's you know, anything that exists on the internet could have problems. So okay, so I think that's the basics of the course, how I'm going to lecture, all those sorts of things. I'd like to get to a little bit of code writing today. So one more thing related to coronavirus. I would say for most people, if you have a laptop, bring it to class. Did I already go over this? I do these same speeches over and over again. They're supposed to be cleaning the keyboards, but I think with everything else, like anything in the world, you have to look out for yourself. So if you do have a personal laptop, I would suggest bringing that because, again, these are shared keyboards. I think they're supposed to be cleaning them once a day, but like I said, I already haven't had another class in here at 9 a.m. I used to use the teacher station, but you can see here I'm bringing my own. And you're also welcome to bring some sort of, you know, something to wipe the keyboard down beforehand if you don't have your own laptop, just to be certain. And then I would highly suggest afterwards washing your hands. Now, I don't know how, I keep on seeing conflicting reports about how much of this thing is spreading through the air versus surface to surface. But worst case is that you just washed your hands a couple extra times, you know what I mean? You just took some extra precautions if it turns out it's not spreading via keyboard. So, so I think that's it. Any questions? Looked like there were a lot of people had courses with me before, so I think you get the idea. Does anybody know how fast this class filled up? When I checked my schedule mid through the summer, it filled up this class filled up pretty quickly.
Yeah, I was on the day of registration, like when it started.
Yeah.
When I was registered for the class, 5 people had already signed up.
Oh yeah,
Yeah,
so.
I was the last one to attend, and I got to keep in mind I registered 2 hours when it started.
Oh, so it filled up quick, yeah.
Yeah.
It was actually interesting.
Last second, so somebody dropped it.
Oh, okay, so I think it was very surprising to a lot of people that there was such demand for live classes. Because like I said, I was kind of, I wasn't checking too closely because everything's always, being shifted around. But I checked maybe a week or two after people could register, and I think pretty much all my live classes had filled up. And I think that it was very surprising to a lot of people that there was so much demand for live classes. I understand. It's tough to learn some of this stuff just, remotely like we already talked about. So, but anyway, yeah. So any precautions that you can take on your own, like bring your own laptop, do that. Yeah.
Yeah, this is like my only in-person class.
Yeah.
So I have to take database programming, Java, and Linux fundamentals online. So
Just out of curiosity, how many people that kind of you're in a similar schedule, you're forced to take a lot of online stuff just because there wasn't a lot of live, most people?
GI Bill only pays half if you're taking all online.
What's that?
GI Bill only pays half if you're taking all online.
Oh.
So I had to take at least one live.
Okay, so it's good you got this one in here at least. Okay, so one of the things I like to do, and if anybody's had classes with me before, you probably heard this speech before, so I'll try to go through it kind of quickly here. I'm not a huge fan of PowerPoint slides. So a lot of times you'll see me just hop over to Wikipedia. Here we go. Okay. You can see here, by the way, this is the history of computer. Let me get to, we don't care about analog computers. There we go, modern computers, perfect. So you can see here, there's a bunch of prehistory on computers. They used to have mechanical computers. And the first computers tended just to be like very fancy calculators. So a lot of computing, when it really started to take hold, was around World War II. What was happening during World War II? Okay, well, rockets had just been, you know, I don't know if I could say really invented, but rockets and missiles, we started to use them a lot, and we started the space program. And so there used to be rooms and rooms of people who it was just their job to calculate these rocket trajectories and all kinds of things like that. And they would just do all these calculations. Now there's a guy named Alan Turing. How many people have heard that name before? He recently had a movie made about him. I haven't actually seen it, but he's a very famous mathematician. He actually, so he's famous for creating the first modern computer, at least on paper. What's the other thing he was famous for during World War II? He actually broke a bunch of German encryption. He is, yeah, super smart guy. And one of the things he did was he created, on paper, essentially the first modern computer. Before it was even, it's not like he sat in his garage building this thing. He just sat on paper and mathematically came up with this computer. It's very clever because he was able to prove mathematically, and there's actually a name for it now, Universal Turing Machine. Anything that you could do with math, this machine could do. That was super powerful because what does that mean? What can I do with math? Well, I can do simple addition and subtraction, but because I can kind of stack these things, what can I do with addition and subtraction? I can start to do algebra. I can stack that and I can start to do some calculus. I can start to do some trigonometry. I can do all these really cool things. And so by proving that, people said, well, right now, we've got rooms and rooms of people that their job all day is to calculate things. If we could make a machine to do this, we could replace hundreds of thousands of people with a single machine that could do a calculation that might have taken them days to do in seconds. And so he worked with a guy named, so Alan Turing came up with the first like mathematical model of a computer. Then a guy named John von Neumann actually came up with a computer called the ENIAC. And that's really like the first what's considered computer. And they made it all with vacuum tubes. Now I'm going kind of far back here, but there's a reason I do all this. Is because when they came up with these first computers and these first programming languages, what type of thing were they trying to solve? What was their goal? Was it to create web browsers, Microsoft Office apps, like mobile apps? What was their main goal? Yeah, things like that. So like weather simulations, rocket simulations, anything regarding like if I wanted to shoot, if I wanted to get the Saturn V rocket or something, if I want to shoot that off and get it to the moon, those types of things. Those types of things don't really need a computer mouse. They're not really what we call interactive applications. A lot of it was that you would write code at a text terminal, and even then it was even a little bit more primitive. But there wasn't a lot of graphical interfaces. Actually, there was none back then. And so when we're learning a new language, the way I like to teach it is that when you're learning the fundamentals, you kind of have to put your mindset back then. And so those are a lot of the programs that I like to teach initially are those types of programs. Simple conversions. I use conversions a lot because they're simple conceptually to convert between, a mile and a kilometer. It's just some number multiplied by a number. But we can really take that example and we can spin it 10 different ways to do some really cool things. Learn about functions and loops and finding averages. All these very, very basic things. Now, it makes it sort of tough because I know some people in here want to get into advanced things, but we kind of have to start off with the simple things first. So that's why I bring that up, is because a lot of these languages, the way they created them, they didn't create them as like you would say, for example, like Visual Basic, where you do a lot of drag and drop programming. Visual Basic they created for a very specific type of programming. With a lot of these other languages, even though they're not that old, Python is actually from the early 90s, which is like, for reference, C was created in 1970. So in the 90s, they definitely had web browsers and they had all these other things. But these languages are still like, we still have to kind of focus on the fundamentals of just doing simple calculations, very basic things like that. Okay, so that kind of sets your mindset of the types of programs that we're going to be writing initially. We're not going to be writing graphical programs and mobile apps and things like that. We're going to stick to conversions, finding averages, those things like that. So now let's talk about Python specifically. So there's a lot of history. It says it's conceived in the 80s. I really kind of think of it as like an early 90s language. I don't think it really kind of formed as a language until, yeah, you can see implementation began in December 89. And this guy is very famous in the Python community. I always mispronounce his name, and I'll mispronounce it this semester again, but Guido van Rossum, I guess? I don't know how to pronounce it. Anyway, he's kind of the leader of the language. The language very much is like a community effort, but it's almost like with Linux, where it's a community effort, but Linus Torvalds really is the gatekeeper of everything. He kind of is the same way. Now, I'll give you a quick history of how I learned Python. Is that a long time ago, I was working in IT. I was doing kind of half programming, half system administration. And at the time, there was this, I don't even want to say it was a new language because it had been out a while, but a lot of people were just all of a sudden using Python for automating system administration tasks. For example, if I had to set up a new user, rather than typing a bunch of commands or putting together a bash script or something like that, or if it needed to do something more advanced like networking stuff like that, it's very cool because you could use this language, Python. There was actually another language called Perl, which a lot of people used to use. It's very difficult to read. And so that's how I learned it. It used to actually kind of be considered a, I don't know the right way to say it, kind of like not quite an esoteric language, but it definitely wasn't a top 10 language. It wasn't considered with the tier of like C, C++, Java, those sorts of languages. It was considered maybe at a little bit more esoteric of a language. And then what happened? Well, the history is a little bit weird and complicated. It's just like a bunch of things randomly happened, and then all of a sudden Python became an incredibly popular language. So a lot of scientists really liked a language called Fortran. Has anybody heard of this language before? And it's a kind of difficult language to use, but scientists love it. They got really, really good at it. One thing it was really good at doing was linear algebra, matrix algebra, which is a really, really powerful field of mathematics. It actually forms the whole basis, linear algebra, plus a little bit of calculus, really forms the basis of all modern AI. All modern AI can really be distilled down to in some matrix operations and some calculus. So scientists love it. It's not an easy language for most people to learn. And so there were some scientific grants in the early 2000s where they said, okay, we need a modern version of Fortran. Fortran is a very, very powerful language, and it's got a bunch of scientific libraries, reusable software available for it, but we need something that's a little bit easier to use. And so they came up with this software package called NumPy. Has anybody heard this before? NumPy? You might have, if you've done any Python programming, you might have heard of it a little bit. NumPy was really, really powerful because what they did is they created some layers on top to where you could use a bunch of linear algebra packages in Python. All of a sudden, these scientists doing number crunching and data crunching, they're like, wow, this language Python is so much easier to use than Fortran. I get all the power of Fortran and the speed, but I get to use the simpler language because it's essentially calling that code. At that time, let's say 2005, 2010, somewhere around that time, what was getting really big really quickly? AI, machine learning, neural networks, all these things. Google was a very early adopter. And what they did is they sort of recognized this, and they said, well, we can continue to do all of our AI and machine learning work in C and Java, but these languages just really aren't good at it. Fortran's really good at this, but Fortran is kind of a difficult language to use. The scientific community knows it, but most of our programmers don't know it. What's a language that we can teach them really quick to get the power of that's simple to use? And so they very early on adopted Python. This isn't the case anymore, but in the early days of Google, they had a philosophy. If you can write it in Python, start there. If Python's a little bit too slow for it, write it in Java. And if Java's too slow, write it in C++. And those, for the longest time, were the 3 core languages. Things have gotten a little bit more complicated since then, but you can see. So Google's a gigantic company, and if they adopt something, you can imagine that people start to recognize it. Okay, they actually, Google for a while employed the founder of the language, and I don't think he worked on very specific projects. I think they just paid him just to work on Python. Like that was his job. They just thought it was such an important language. They kind of just wanted to pay him a salary just to work on this language. He eventually left. I think he's at Dropbox now. But that's the history. So this language that went from kind of an esoteric language 20 years ago and they have all these different programming language rankings. I kind of trust the IEEE one. Yeah. Yeah, so all of a sudden you've got this language. Now don't take this as being exact. I would say you could switch any 2 spots and it would still probably be accurate. So you could probably switch Python and Java or something like that. But it's going to be pretty close. And again, IEEE, they have a little bit more of a research angle toward it. But you can see all of a sudden this language is just incredibly, incredibly powerful. If I were to go on to... So how many people have heard of DICE before? It's a tech job site. And let's kind of do like a metropolitan area. Let's say Boca Raton. Does it show the number of jobs at the bottom?
Jobs per page, 20, there's like 5 pages.
Yeah, so we could say roughly 100 jobs.
725.
Oh, 725, perfect. Yeah, so just in this area, some of these are remote, but let's just say exclude remote. Okay, 24, which is pretty decent for programming jobs, especially during a pandemic. And that's just one specific site. That's just DICE. So you can see there's jobs out there. And one of the nice things with Python is that it's a very generic language in that you can do a lot of cool things with it. So for example, how many people have heard of a language called Swift? And so what's the main thing you do with Swift? What types of programs and what ecosystem would you write with Swift? iOS apps, pretty much. And that you're pretty much stuck doing that. What's nice about Python is once you learn Python, yeah, it's used for machine learning and AI, but if you have no interest in that, it's also used with this framework called Django or another one called Flask for doing web stuff. You can make games in it. Now you're going to be kind of constrained on the types of games, but people make games in it. You can do system administration. There's a lot of automation. I talked to Professor Stroth, and he tells me that Cisco is trying to do a lot of automation. Like if you have a bunch of new network equipment and you want to automate, it's set up and automate a bunch of other things that they're moving over to Python. And a lot of these people who were once network administrators and probably thought they would never have to learn any sort of programming at all, now they're all of a sudden rushing to take Python classes because that's sort of the official language that Cisco has adopted for doing automation. So it's used for a lot of things. That's a lot of the history, but So any question on the history? I just wanted to give you a sense of how it got popular. It's mostly because of Google, but it's a pretty decent language, but because Google really put their weight behind it, even though they didn't even create it, it really got really popular. And actually, so NumPy was one thing that made it very popular, and then this other library from Google called TensorFlow for doing neural networks. So they released this, and I think in 2015. Before TensorFlow, it was very, 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 very complicated to create neural networks because you have to do a bunch of calculation a bunch of calculus for something called backpropagation. And so pre-2015, pre-2010, that era, not a lot of people were using deep neural networks because the mathematics were super, super, super complicated. And once they released this TensorFlow, which did a lot of those things automatically for you, it's a very, very clever library. I don't think they created themselves a lot of these techniques. They just made it very accessible. And they made a simple to use library where all of a sudden now I can create neural networks. And really 2015 was when I really saw the language explode because all of a sudden you had all these neural network researchers wanting to create neural networks in TensorFlow. And because TensorFlow is a Python library. So just some history. We're not going to probably use TensorFlow in this class. It's a little bit too advanced, but these are just kind of some of the reasons that all of a sudden this language that nobody really talked about 20 years ago is number one on a lot of these lists. Okay, so any questions about the history or any of that? Okay, so that's the boring stuff. I know, trying to keep everybody awake in here. For the most part, we're not going to talk about things like that. For the most part, like I said, I like you to write code. So let's go over to under resources, the link for REPL. Go ahead and click that. If you have an account, you're welcome to sign in. Just make sure to sign out afterwards. If you want to take 30 seconds, I think, to create an account, I think they just ask for basic things like an email, name, something like that. So you're welcome to. Normally, I try not to introduce too many outside things, but I always do like to give a little bit of history with a lot of this stuff because it kind of sets the tone. It tells you why it's even worth learning Python, you know, the types of programs we're going to be writing and that sort of stuff, rather than just day one, just jumping in and being like, you know, let's write some code. It kind of sets the stage a little bit, even though it can be a little bit boring hearing all this history. Okay, so they have a code editor area, and they have, like if you were doing Windows programming, you know how you have the command prompt, cmd.exe. That's kind of what we're simulating here. Right, so on the right, you could think of this as the equivalent, and then in the middle here, that's your code editor. We're not going to probably, I mean, maybe toward the end, but if you have a multi-file program, you can actually manage that here. Right now, we're just going to have one simple main.py. And I'm going to try to keep the fonts nice and large because we're not using any of this. I'm just going to scoot it over for now. Okay. So what's the first program you always write in any programming language?
Hello world.
Hello world. So let's start off with that. So we'll type in print. And like I said, the expectation is that you're supposed to write this code along with me. There's just something about writing code, getting that muscle memory. Can everyone see, or should I turn it a little bit darker? Are you okay with the lights? So you say print hello, and then run the hello. What's that?
A lot faster than C++.
Yeah.
Yeah, or at least much more concise.
One line
Yeah.
versus like 5.
Yeah. So even though this is a relatively simple program, there's actually a lot going on here. So the thing between these single quotes right here is what's called a string. Everyone remembers strings from other programming languages? A string is essentially, so we have some very basic data types. We have our numbers, like integers and floats and doubles and so forth. And then we have strings. Strings are just strings of individual characters. You can't really do math on strings. Like you'd have to do math on numbers, but it lets you do things like, like this. This is hello, okay? Now in other languages, they're a little bit more strict and formal about how you define a string. In Python, you'll see me do this, and I actually just caught myself doing it. The single quotes and double quotes for strings are interchangeable. So what that means is that this print hello and this version are the same. Even though one has single quotes and one has double quotes, they're the same. Now, why do I often write the single quotes? It's just for no other reason than I just don't end up pressing the shift key. As simple as that. This does not work in other languages because other languages reserve the single quotes to mean a single character, and then the double quotes are a string. But Python kind of treats them the same as far as you're concerned. You do have an individual character, but we don't really use that often. So just keep in mind these are interchangeable. Now this thing right here, this print, is called a function. Does anybody remember functions? Okay. Now this isn't a function that you wrote. It's a function that somebody else wrote. We'll get into functions, but just for those that you do remember, that's what it is. So we've got our print statement. Let's talk about variables, okay? So let's say, for example, I've got a variable here called name. You can put in your own name. Let's put in my own name. Now I run it. The output's not going to change. And we'll get to that in a second. I mean, this is not a trick question or anything. Why don't you think the output changed? Yeah.
You just put your variable as an output?
Exactly. We didn't actually. So we ran code, but because the code didn't actually output anything, this additional code, it just kind of happened. So I'm going to sort of assume that most people in here came from a background of COP2030, just to show hands how many people took that class. So pretty much everybody. Is there anybody else, anybody who got their experience not from COP2030 but some other class? Okay, because a lot of times it's just easier for me to say, hey, remember that concept from COP2030? This is how it works in Python. So we declared, we kind of did our variable declaration and assignment in one step. If I had written this in C++, what extra thing would I have to had?
Oh, variable type?
Exactly, a type. I would have had to write, actually, a couple of things. I just thought of it. So we would have had to write that it was a string, but we don't have to write that. Whatever we assign name to, it says, oh, okay, this is a string. Name is just a string. Now, I should have stated this earlier. So, some of this stuff I forget because it's so detail-oriented. What other thing at the end of the line are we missing that we might have had in C++?
Oh, the colon.
Yeah, the semicolon. So in Python, we don't have semicolons at the end of the line. Now, this throws some people off because the end of the line is basically the enter key. Now, what happens if you want to split up code over multiple lines? So don't write this, but it causes problems. Okay? With C++, it just keeps on reading. It doesn't care about the enter key because it just looks for that semicolon. But because we don't have that, with Python, it says, okay, whatever the end of the line is, that is your end of the line. So it means that sometimes if you have a complicated piece of code, you have to go a little bit of work to split that code up into multiple lines. So if I wanted to print my name, I could do print name. So just like in C++, rather than actually putting in the literal string, I can just put a variable in there. So just a quick check. Everyone's able to type okay. You're able to run it and compile it. Everyone's doing good? Thumbs up if you're doing okay. Perfect. Okay. I try not to move too fast, but at some point it can get so slow that I start to lose people. So there's a balance. So I've printed the name. We can see that here. So what if we did some other number, let's say, or some other variable, let's say I. Well, let's come back to that. What if I wanted to say, hello, Chris? So that's a little bit tricky. There's a bunch of different ways to do it, and as the language has evolved, we've actually come up with better ways. So one way would be to say, print hello plus name. I personally don't care for this version, even though in previously I had to use it a lot. Because if you're trying to do a lot of things with variables, let's say 3 or 4 variables, it can really break up the flow and it can kind of difficult to see what's going on. It's kind of tough to see that with this very confined example. So that works. There's another way that I'm not even going to bother showing you. It's just so, I'll show you, but we're not going to use it in this class. It's just so complicated. I just want you to know this is like the bad old days. This is how we used to have to do things. Okay, that's another way. Does anybody see why I don't particularly care for that one? It's a little bit tough to read. I used to use this a lot because it could be convenient, but we actually have a nice one. So you'll hear this term. Sometimes they're called F strings, F as in Frank. I think it stands for format. This is the version I like the most, and this is what we'll tend to use in this class. Now, it's only in the past, let's say 3 years, that the language has included F strings. So if you're ever in a situation where you're using an older version of Python, this isn't going to work. But the nice thing about REPL is that they do give you a pretty recent version. And I like these F strings. What you do is you just put you put the F just to the left of the quotes, and you say hello. And then inside of braces, you just put the variable. So that's the version I tend to like the most, because it kind of mixes the variables and the names all together. Now, this may seem like a silly question, but why can't, so I'll leave that there. I'm just going to erase this, so don't worry about typing this. Should be obvious, but why can't I just write that, like on line number 10? Exactly, it's just going to say hello name. So that's why we need these special braces, is that it lets it know that it's a variable. Okay. Some other languages you actually may see this. So this isn't Python, but some of you may have seen that before, like in Bash scripting or Perl or something like that. But they don't use that character in Python. So to me, just out of curiosity, how many, just vote. So how many people think this one's the most clear? Show hands. And again, it's a personal preference because a lot of people still use all 3 of these. How many like the second and third? Okay. Yes.
I think it's mostly because if you use the first one, you have to remember to put spaces afterwards as opposed to just having the whole thing.
Oh, that's very good. Perfect. Thank you for bringing that up. Yeah, one of the things, and I'm just used to this, but and I'm sure some of you may run into this in COP2030. How many people have done something like this where you forgot to put the spaces in, and then when you ran it, it's all squished together? You've seen that? So yeah, you're exactly right. That's one of the things I like about this is because it's all within the double quotes. And so what you see is kind of what you get. It's going to say hello space name. You don't have to remember some of these other things. There's another reason this is going to become interesting. And this will probably be the last thing we do for today. And then we're here till 12:15, right?
Yeah.
Okay, so this will be the last thing, just to give you a sense of the course, how it is. So this is a string. Let's say, for example, I have GPA. Now, what if I tried to do something like this? So the GPA is going to be GPA. Now, most sane people, what do you think line number 11 would print?
It's not gonna print that because it's numbers.
Yeah.
That's the word for it.
So for most sane people, you'd think it would say GPA and then the GPA. But unfortunately, it gets kind of complicated because it's saying this plus right here is a special character called a concatenation operator. And so it can concatenate strings, but then it tries to get into a string in the number. So you can fix this, then you have to cast it to a string. But one of the nice things about F strings is that we don't have to worry about any of that. All we do is just say GPA is GPA. This is actually one of the reasons I really like this F string syntax, is because it automatically is able to interpret variables, and you don't have to get into all kinds of other things. So this is generally what we're going to be seeing, but in some tutorials and other things, you may see some of these other things. That's why I like to go over them. But for 99% of cases, we're going to stick to this. Now, I've already mentioned this, but just to kind of reinforce this, there's actually a special function called type that it'll tell me the type of any variable. So if I do type and I want to know the type of name, well, I already told you that it was a string. Now I run type, nothing's going to happen. I have to actually print that and here we can actually see more formally that str is just short for string. And we could do the same thing for GPA. And that will be a float. For those of you that took COP2030 with me, you can, floats and doubles are basically the same thing. It's just how much precision you have. But for this course, you know, at a high level, if you want to simplify, you can think of floats and doubles as the same thing. It's just basically a decimal number. We'll get into why it's not exactly a decimal number at some point. But it's, as far as you're concerned, it's a decimal number. So even though we never specifically said that name is a string and GPA is a float, just the fact that we initially assigned it a string and a float means that they became a string and float. Now, what that also means is that, you know how in C++ and C languages you could declare a variable without giving it a value? So what I could have done is I could have said float GPA and left it at that. Can't really do that in Python. And can anybody guess why? Because it needs that initial type. And so it doesn't get that type until we give it a value. Okay. It's tough sometimes because some of this stuff, it's like you get it intuitively, and there's a reason, and the more I explain, the more confusing it gets. So sometimes I have to stop myself from over-explaining some of this stuff. Yeah.
Oh, how do we add a note to Python? Like
Oh, comments. Yeah, so that'll be the last thing. Perfect. So comments are slightly different in Python than they are in C++ in most C languages. So in C languages, you could either do the 2 slashes or you could do like that sort of thing. I should type it right. There we go. In Python, they actually took it from another language. What you use is the hash symbol, and you'll notice that it's grayed out. And so anything on that line is not interpreted as code. So those are called comments. Okay, so I think that's a good stopping point for today. Usually what we'll do is we'll just, right when we get in here, get right into coding the whole class. But I just wanted to give you a little bit of background and history on the language. Some sense of, if anybody who hasn't had me for a coding class before, some sense of how we're going to write. This is pretty much going to be it, is that we're going to write code like this on the board. I'll explain things along the way, and you'll type it. For anybody who hasn't created an account and just wants to save this, what you do is you can click this save button right here, and it does two things. See how it created kind of a funny URL here? Sane blushing binary tree. This is actually unique, so if you wanted to, you could take this and email it to yourself. Or if you want, you can always, remember that download button that I showed you earlier? I kind of hit it. I don't know how to show it again. Here we go. My fonts are so large, it's kind of hard to see, but you could take this, this one, and download it. Or you could take this unique URL that it creates for you, and you could just email that to yourself. Or you could always take your code and copy and paste it, but probably one of those two methods. Or you can very quickly create an account. Okay. That was actually one of the most interesting unintended consequences that I found of using REPL, is that people used to lose their code all the time. And I don't have that problem anymore with people just flat out losing code, because it's much easier to manage inside of REPL. So, okay, so we didn't stop very much early, but at least you got a little bit of a sense of the language, got to write a little bit of code. So any questions on anything Python related, how the class is going to go, assignment schedule? Oh, did I mention this already, the attendance? Do me one quick favor. The school requires attendance from everybody the very first week of class. After that, I don't care. I don't do attendance grade or anything. This is literally just for IRSC. You don't have to do it right now if you've already packed up your stuff, but sometime before the end of the week, under assignments, go to attendance and just click submit. It automatically attaches your name and everything. You'll get a whole free bonus point for it, because I figured that if you're going to take the time to do it, I'll at least give you 1 point for it. And then that's all you have to do. That'll be the only time you ever have to do it. You don't have to type anything or anything. It just automatically attaches your name and everything. I just need some sort of proof that you were here today, or that you watched the lecture at home. Okay, so I know it's going to be a very interesting semester with coronavirus and everything going on. Please stay safe. Make sure that if anything comes up, stay in communication. If you fall behind at all, please stay in communication with me. And hopefully it's going to be a good semester for everybody. Everyone's going to learn a lot about programming, and optimistic that everything is going to go great. So we'll keep our spirits high. Okay. All right. If there's no other questions, I'll see everybody next week. And then check any announcements of anything I might think of. But other than that, I'll see everybody next time.